So today we're going to test the effectiveness of an over-the-counter orthotic in a running shoe to see how the structural parameters of that shoe change when adding the orthotic. The shoe that we are going to test is the ASICS 1007. It's size 10 and it's got a 10 millimeter heel to toe drop. So we'll be testing this shoe with and without a over-the-counter orthotic. The orthotic that we wish to utilize is the Superfeet. It's one of our most popular orthotics that we use in our sports medicine center. So we'll be testing that with the over-the-counter orthotic in the shoe. We'll be testing for shoe stability index, hindfoot stability, midfoot stability, vertical support, and the rebound index. And we'll compare the shoe with and without the over-the-counter orthotic. As we're going to place the orthotic in the shoe. And just for the heck of it, we're going to see what the difference in weight adding this orthotic. So that is about 11.8 ounces. So adding the Superfeet to the shoe adds another ounce. Without the Superfeet, it's 10.8 ounces. So let's go ahead and test the shoe and compare it to the shoe without the over-the-counter orthotic. We've already preloaded the statistics without the orthotic just to save us time. So the first thing we're going to test is the midfoot stability of the shoe. And we're going to do that by twisting the shoe 15 degrees and measuring the resistance it takes to get to that 15 degrees. That is measured in inch pounds. So the more inch pounds, the more stable the shoe, the less stable. So let's start with this. And we have 54 inch pounds, so we'll stick that in here. Okay. Now the next thing we're going to measure is the firmness of the midsole under the heel. And the firmer that midsole is, the more stable it is in the rear foot, and the softer that midsole is, the less stable. So let's go ahead, we're going to compress this to 100 pounds and measure the number or the distance it takes to get to that 100 pounds. The less distance, the more stable, the more distance, the less stable. Okay? And that's 6.58 millimeters. So now we're going to stick the 6.58 millimeters into our calculator. And we've got that. Now the last thing we're going to measure is the rebound index. So we'll come on over here. What we're going to do is we're going to compress the rear foot to 100 pounds. We're going to release this lever and this will fly up and it'll measure it in millimeters, so it'll give us a measurement of the rebound. So let's go ahead and start. And we'll get it to 100 pounds and we'll release it, and we have 9.56 millimeters. So let's stick that in here. So now we have all our data here. So when the shoe had the orthotic in, it had an increase of midfoot stability of 3.85%. In the rear foot stability, it had an increase of 13.19%. The overall stability rating increased by 15.75%. The rebound index dropped because of the insert, and that's normally what we see as the shoe gets more stable, the rebound index will be less. So the whole shoe stability index increased from 50.8 to 58.8. So if we look at that on a schedule of 45 to 50 shoes tested, we can show you where that shoe has moved up as far as stability ratings and who should be in that shoe. One of the most important thing that the orthotic has done is it's increased the vertical support heel to toe drop by 41%. So in other words, the vertical support without the orthotic was 2.42 millimeters, which is in the minimal level of vertical support, and it increased it to 3.42 millimeters, which is, what that means is that when you're in the weight-bearing portion of gait, your heel is dropping less with the orthotic, and that puts less eccentric load on muscles and tendons. So that's very important. So this 41.32% increase in vertical support, I think, is really important. So now we can see that the shoe increased in its overall stability by 15.75. So before we put the over-the-counter orthotic in, we had a shoe stability index of 50.8, and that still keeps that shoe in the minimal level of stability. So usually a shoe like that should be probably worn by someone who has a neutral gait and is of light to moderate stature. So as we put the orthotic into the shoe, it increased to 58.8. So that brought it up into the moderate stability shoe. So that means that there's more people that can actually use that shoe, from a neutral to a moderate, pronator of light to moderate stature. So you can see the importance of having an orthotic added to your shoe. It definitely adds a lot more stability. So anyway, that's a case for over-the-counter orthotics. They help people.